In this video, we're going to talk about transforming and graphing quadratics that are in vertex form. So here we've got our general equation of a quadratic in vertex form with our A, H, and K displayed. We're going to talk about what kinds of transformations those values in those particular places take on. So we're going to start with the A value. So the A value indicates that there's going to be a vertical stretch or shrink that happens. And we can tell based on the value of our A. For a stretch, our A value is going to be greater than 1. And for a shrink, our A value is going to sit between 0 and 1. Now what about a negative? Well, if our A value is negative, that's going to show that there's going to be a reflection across the x-axis. Our H value lets us know that there's going to be a shift either to the left or to the right. Now, if we see a minus sign inside, that tells us that we are going to shift to the right. And a plus sign would tell us we are shifting to the left. It's helpful to think of anything that happens on the inside of the parentheses is the opposite of what you would think. The K value is going to shift our graph either up or down. If we see a plus sign, it will shift it up. And if we see a minus sign, it will shift it down. So let's move on to an example. Describe the transformation g of x from the parent function f of x equals x squared. So notice here that our a value is a 1, there is no h value, and there is no k value. So this is the parent function of our quadratics. So after we do that, then we're going to graph g of x. So in this first problem, notice that we have a 1/2 out in the front in the a's spot. So that tells us that we're going to have a vertical shrink by 1/4. Then we can see that we have a 4 in the h's place. And because we see a minus on the inside, that tells us that our graph is going to shift to the right 4 places. Now there's some helpful information when graphing. It'd be really nice to know the vertex. And this is called vertex form for a reason. And the reason is because our vertex happens to be our h value and our k value. And our axis of symmetry is x equals h. And so that's going to come in kind of handy. So as we come down to letter A to graph that, we can see that we are going to have a vertex at the point 4, 0, because there is no k value. And we're going to have an axis of symmetry of x equals 4. So now we just want to make a table. So we're going to have our x and our g of x. And we want 5 places. And we want to put our vertex in the middle. So we're going to put our vertex right here in the middle. So we'll have 4, 0. And now we want to make 2 numbers bigger and 2 numbers smaller. So 5 and 6 and 3 and 2. And then we're going to go ahead and we're going to plug these values. So we're going to plug these values into our equation. And we can do that simply by plugging it into our calculator. Now, if I'm plugging this into my calculator, I'm going to have it say 1/2 times 2 minus 4 quantity squared. So it's really important to make sure you put that 2 in parentheses there. Okay? So if we plug that into our calculator, or work it out by hand, that is going to give us a value of 2. Now we're going to plug in the 3, and so we would remove our 2 here and plug a 3 in its place instead. Doing that gives us a value of 1/2. Now, because it's a quadratic, that means we have symmetry, right? We have symmetry. Now, because we picked numbers that were 1 away and 2 away and 1 away and 2 away, then that allows us to say that our values that are 2 away will have the same y value, and our values that are 1 away will have the same y value. And now we're ready to graph. So we'll pull up our graph. I'm going to go ahead and make my xy coordinates right there. And now I'm ready to graph. So I'm going to be graphing, let's count by ones on our x's, and then let's count by halves on our y's, just so that we can see that change a little bit better. All right, so first thing we're going to graph is our vertex at 4, 0. So 4, 0. So there's our vertex, and there's our axis of symmetry. And now we can start graphing our points. So I'm going to graph these in a bright green. So we're going to have 5 and 1/2, and we're going to have 6 and 2. That is definitely not 2. Let's try that again. And then we've got 3 1/2 and 2 and 2. And then from there, we can graph those. And now we see that we have our graph. Now the parent function of our x squared would have had a vertex at 0, 0, and then points at 1, 1, and at 2, 4. And so if we graph the parent function here, we can see the change. As we see, we have a vertical shrink by 1/2, so it went from a 1 to a 1/2, right? So it shrunk down, and it moved to the right 4 places. And then I went ahead and I labeled my graphs f of x and g of x so that I could see the difference. So I'm going to have you do letter B on your own. So I want you to go ahead and push pause, and then when you're done, push play, and let's see if you were right. So you should have started off by saying that there was going to be a reflection across the x-axis, a vertical stretch by 3 is going to move to the right 1 and up 6. With a vertex of 1, 6 and an axis of symmetry of 1. Then you should have made your table with the vertex in the middle, then you should have chosen 1 number bigger and 2 numbers bigger, and then smaller, so 0 and -1, and then plug those into your equation into the x's spot. Plugging that in is going to give you the values of 3 and -6, and then using the fact that this is a quadratic and so it's got symmetry, we can say that those 2 numbers are the same and that these 2 numbers are the same. And we are now ready to graph. So we graph our vertex at 1, 6. So let's say what we're going to count by. For this one, I think it's better if we just count by ones kind of all the way around. All right, so you should have graphed your vertex and your axis of symmetry. Then you should have graphed your points. And that is our g of x. And if we were to have our parent function graphed, we would see that that would look like this, which we can see is definitely different from what we have. And so that is how you graph quadratics in vertex form.